Bom dia, pessoal. Tudo bem? Prazer estar aqui com vocês. Excelente evento. Me pediram para falar em inglês hoje. Eu acho que tem muitos de vocês de fora. Então, vamos treinar um pouquinho. I'd like to speak with you today about AWS and innovations and trends I've been seeing in cloud computing in general. I'm Julio. My job at AWS is to talk to developers and help you guys be successful in here in the hackathon and the technical events that are going on. But anything at all that I can help you with AWS and cloud, it will be my pleasure to go hands-on and build things with you guys. So just to give everybody a rough idea of why AWS, and of course there's many answers to why choose AWS. I picked up some cases and friends to share the stage and show you guys what is possible and what's new and what you can build with these technologies. And in this case, the first example I would like to share is from Major League Baseball. Major League Baseball is an enterprise that builds applications and media for baseball games in the US. And this makes it pretty clear the value of AWS. They get like 7 petabytes of data per game. In a whole season, that's 17 petabytes. And the interesting thing is, after the season is over, they don't get to spend any money, right? Because they don't really need to pay when they're not using. That's the whole idea of cloud computing, right? And with this, what they built is an app called StatsCast, where they can measure and track baseball, the players, the ball, and build the stats. Baseball is a very data-intensive game full of statistics and bets and there's a lot of, it's a very data-driven game nowadays. And here in this example, it was a play from 2014, and they could show, for example, that if this guy that did this dive towards the base, if he would run instead, he would make it to the base, and proving an old saying in baseball that you don't slide into first base. And this was from Joe Inzerillo from Major League Baseball. And instead of just talking about him, I thought it would be better to show a bit of himself. And this, of course, is done with stereoscopic cameras and radar precision, military precision radars to track the ball and be able to generate this data and the images that go along it. And what's the AWS value in that? I would let for Joe to say.
When you look at the cloud market, there's really only one leader, both in thought leadership and in scale, and that's AWS. AWS Cloud has really been one of the most impactful changes in my history in IT. And I think that what it really does is it enables the individual developer or development team to be more effective by automating a lot of the mechanics of what it takes to get an application to market or to get an update to market. One of the things about professional sports in general is we don't play 24/7. So the ability to have an elastic element to this is very, very important. For the months that we're in season, we obviously have a good deal of information coming in addition to all the historical data that we have. But in the off months, we're not generating new information, but we are taking a look back and trying to reuse a lot of the historical information to provide greater context. So the ability to spin up more resources when we need them and spin them down when we don't is a great part of the economic model that makes this possible.
So that's the whole idea in this case. There's 2 things that he mentions. The ability for every developer, anyone, the same services that we offer for them is the same that is available for each one of you. And you can spin the whole thing up, and when you don't need it, just shut it down. And in this case, from Major League, one of the key services that they use is Amazon Kinesis. Amazon Kinesis is a streaming data service similar to what you would build with a Storm or other data streaming solutions, but already out of the box and ready to use. And it's a three-piece service. It has streams. That's the bare bones message queuing system. The Firehose, if you don't want to process this data and just store it, this makes it easy just to store this data on S3 or Redshift. And Analytics, where you can run SQL queries directly into the data that's going through the pipes. Let me show you guys a bit of Kinesis. So this is the AWS console. If you go to the Kinesis management console, you can see those three services here. Let's take a look at streams, for example. And when you create a stream, all you need to do is a name, for example, events or whatever you're streaming, and the number of shards. Each one shard is able to write 1 megabyte of information, and you can read 2 meg per second out of each shard. And this is just it. If you need to scale, let's say you have a gig per second, you can just scale as much as you need. Right now, my account has a limit of 500, but this is a soft limit. You can raise it anytime. And other than Kinesis streams, we could use Firehose to store this data and run SQL queries on the data that's stored, or Analytics to use SQL in the data that's currently going through the pipes and do window queries, dashboards, alarms on complex events and things like this. So this is just a bit of Kinesis. And this is important for many customers. Of course, this is not just Major League. A few other examples would be AdRoll, that's doing ad analytics, ad impressions, and advertising online. They do 50 billion ad impressions a day and responses in less than 50 milliseconds with Kinesis. Sonos, they build audio hardwares like Bluetooth speakers and audio devices for smart homes and things like this. And one very cool feature of Sonos is that in the years that they've been operating, they improved a lot on their product, because the product only gets events and sends to the cloud, or get things from the cloud and ships to the event. So they can improve the features and the product without going to the product itself. They do it all on the cloud. Or if you want to scale like Lyft, that in 2015 had 50 million rides and tripled that number in 1 year. And for those of you who are in the startup market, you know that a threefold increase in 1 year is not something easy from the technical perspective. And of course, this kind of solution would help a lot. Or Nordstrom, a retailer that does 10 million events a day. 10 million events a day is not so impressive, but one cool thing that I'd like to highlight is that we are probably the most relevant retailer in the Occident, with Amazon, not web services, but being a subsidiary of Amazon.com. It's interesting to see that competitors such as Nordstrom or even Sonos now are getting the same treatment. Everybody's treated equally. It doesn't matter if you are in one table at a hackathon or a huge company, you will have access to the same services with the same quality at the same cost. In Amazon itself is just another customer of AWS, as I will show you in a couple of slides. And all those devices and events, they're not there just for the technical coolness. This has generally a money purpose, and it's very interesting, the study from GE, General Electric. They gathered this data from many industries, and Marco, by the time the CEO, he estimated what increase in 1% in an industry would become after 15 years in terms of money. So the interesting thing is that when you have applications and Internet of Things, and you have a global view of an entire business process in an industry such as oil or aviation or healthcare, 1% is nothing, right? We are targeting gains, efficiency gains, much larger than that. And not only from inedited things, but just by bringing things that are already done and adapting to local markets, you can easily get those the same similar results. And this is where the money lies. And this is a very important question for IoT, because where is the money in IoT is not on prototypes or the things that normally you see as IoT, but building devices and building industries where you can collect data and understand the whole chain of business in ways that were previously not possible, right? And this is an example from this GE case. This is the turbine from a Boeing 787, and they generate a terabyte of information a day. And how does this make any difference? Well, the idea here is aircraft maintenance. If you think, how do you perform maintenance on this kind of aircraft, on this kind of device? You can either set a schedule and send, for example, a technician every, I don't know how many months, but this may be wasteful because the technician may go there and there's nothing wrong and it's functioning perfectly and he just goes home. Or it may be too late and it's even worse, right? So the idea here is, of course, having them serviced just in time when the sensors and the data shows that, and not only the current data, of course, but the whole historic data from the same engine shows that it needs maintenance. And just in the last year, this caused 60,000 preventions in delays and cancellations, helping 7 million passengers. So this ends up, of course, becoming a really valuable platform for GE. And again, instead of just speaking about Marco, I'd like himself.
Electronic sensors have been around for some time, but something has changed. A sharp decline in the cost of sensors, and thanks to advances in cloud computing, a rapid decrease in the cost of storing and processing data. So we are moving to a world where the machines we work with are not just intelligent, they are brilliant. They are self-aware, they are predictive, reactive, and social.
And it's very interesting to pay a bit of attention to those characteristics, especially the social machines that we are starting to see. And it's not easy to build those things, right? We've been working with IoT, and you know how hard it is to get it correctly, especially with security and all. So another AWS service that I would like to share with you is AWS IoT, and it will take care automatically of securing the messages with TLS authentication, mutual authentication. You need certificates for the devices, and everything that goes in goes through MQTT, but on top of TLS. And there is a rules engine where you can say what messages you want to ship to what integration. You can say, well, alarms go to a notification service, data goes to the database, and you can filter and sort messages in a central rules engine. And there's even a device shadow feature, and this is for state management. It is hard to decode state after a sequence of messages. For example, say it's a simple light bulb, and you say it's on, off, and you lose one of those messages. It's hard to say what's the current state of the device. And what device shadows do is, if your device is disconnected, it will buffer the messages, and when it syncs, When it's online again, it will sync and give you the events so you can respond appropriately. So, and I'm sure that if you're building Internet of Things, you know that security, connectivity, integration are really hard problems, and AWS IoT makes that quite easy. And there's a lot more on the oil and gas study. The GE is moving a lot onto AWS, but I would like to show another customer that shares a lot of this philosophy that Mark said about self-aware, predictive, reactive, and social machines. And this is JPL from NASA. And Tom Soderstrom is the CTO of NASA, and he said a few nice words on our last event. Let me play him.
But first of all, if you remember where you were 4 years ago, I certainly do, it was an exciting time where we're going to attempt a crazy engineering trick. We're going to land a 2,000-pound rover 150 million miles away, all by itself, from thousands of kilometers per second to standstill in 7 terrifying minutes. What we did, we tried something new. We tried AWS to give you all the pictures at the same time as we saw them. And let's see what happened, and where were you when Curiosity landed on Mars?
Vehicle reports entry interface. At this time, begin pressurizing the propulsion system to increase the thrust of the system. We'll use that for all the maneuvering in the atmosphere we're about to do. Touchdown confirmed. We're safe on Mars.
So if you remember the Curiosity landing, it was broadcasted to more than 50 million persons worldwide. And the idea here is the same, right? They imagine that they don't need to have anything of infrastructure 1 hour before or 1 hour after the landing. They just have to spend money while the event is going on, and then just use, of course, they use a lot of AWS for the hover, but just speaking about the landing. And the hover also does a lot. So it's, again, those same ideas. The machine, the device is self-aware of its environment. It is predictive of its future conditions. It reacts quickly to the same criteria and we will talk more about predictive and reactive when we discuss machine learning in just a bit. And also the social perspective. It's weird to think how a machine that's alone in Mars can be social, but who took this picture? It's a selfie, right? And it sings happy birthday to himself every year and sends us a video. And it's people, astronomers from the science and from hobbyists all over the world can use the data and the images from Curiosity to leverage all sorts of studies. And this is just an example from their app. So this allows they build this stereoscopic vision from the data from the rover, and the scientists can access the telemetry from Curiosity together with the images and collaborate, because this is the key idea nowadays. The idea is not to build robots and machines that will overcome humans, but to together build processes where you can interact and be more efficient, right? And with this, the scientists can say what they want the hover to do and what's the path that each one is interested and what data they want to collect and so on and so forth. And there is a window of like 1 hour where the planets are aligned to send commands to the hover, and this is how they do it. And distributing this data worldwide is especially important in these cases. And I know you were probably aware that we have a global infrastructure that has many regions and availability zones, and a lot more is coming. We have France, Sweden, the Middle East region, China, Hong Kong, and a new one in the US coming very soon. But one piece of infrastructure that many people don't know about AWS is that we have these blue dots called the edge locations. And this is important for solving the price problem. When we talk about these edge locations, those are just for the services that require low latency, such as DNS responses and HTTP caches. Let's say it's our CDN, our content delivery network, where you can stream video or deliver HTTP traffic from all those locations. And the great thing here is that if you already use AWS, you know that we have different prices per region. It does not cost the same for an instance in Brazil as it does in the US. So with this network of edge locations for CloudFront, in this case our CDN, you can select the region, the yellow dot here that has the most availability of services and the best costs. That's probably the US regions. But it's pretty close with the European regions as well, so you can use Frankfurt. But this is the easy part. We are in the easy side of this decision. But if you're in Brazil, if you're in Asia, things can be a bit more complex. And the solution is the CDN, because you can have all your servers and data in the US or in Europe, as it's important for your context, and deliver this worldwide at low latency and low cost. Okay? And talking a bit more about Amazon, we have this culture of engineering where if a team can't be fed with 2 pizzas, it's too large. It's the 2 pizza team's idea. And well, 2 American pizzas can feed a lot of people, but it's the idea that notion that a team of engineering should have 10, 15 people at most, right? Because, or else it gets too hard, you know, Brooks' law. If you add people to a project that's late, it becomes later, right? It usually doesn't solve too much because the communication paths and the complexity of building huge monoliths of software quickly surpass your ability to communicate effectively, and make decisions and deploy software. And this can be easily seen at Amazon and many other customers. For example, this is Amazon in 2008. The front page of the website. By the time keypad cell phones and watches, that was not so smart as today. But behind this website, we had this. This is our infrastructure in 2008. So this is a map of dependencies between services that collaborate to build that front page. Some of them are public facing, some of them are internal. But each of those was a team 9 years ago, right? So you can see how this can become pretty complex with time. And imagine that you had to manage servers, infrastructure, network cables, and things like this for each of those. So the more automated and the less servers you have to manage in this kind of scenario is pretty important. So that's why we are seeing a huge trend in the serverless space. All this idea that instead of just building servers, let Amazon or let the provider handle the server building, and you just deploy your functions, you just deploy your code, or just save your data, and don't have to manage individual servers at all. And I will let Lynn Langit, there's one of my favorite speakers, illustrate the impact that this can have in your infrastructure, in your app.
So the question becomes, clearly didn't work, how much did the government spend on this project? What was the architecture, and what does this have to do with serverless? The government spent over $9 million working with a vendor, it was IBM in this case, over a more than a year-long period, and had a complete and utter failure. 2 students at a hackathon a month later in Australia, after having attended an Amazon community event, built a complete functional copy of the website in 3 days using a serverless pattern at the cost of $500 and load tested it.
So this was the Australian census, and we have the same thing in many cases because when you spin an instance, you have to pay for a while it's up, and this can be seconds or hours. And with functions, you pay for the 100 of milliseconds. Just when that little function is running, just while your REST API call, or just while that function is executing and responding to an event. And after that, you don't pay anything at all in compute. So you can easily see, in this case, from the vendor, the provider charged the Australian government 9 million to do the same that 2 students did at a hackathon, pretty much like this one, for $500. So this can bring extremely dramatic changes in costs for projects, right? And
now, individual.
This next one is Eric. And the last perspective that I would like to introduce, that's the final piece of this, and let him say it.
Now, individually, digital, exponential, and combinatorial would each be game changers. Put them together, and we're seeing a wave of astonishing breakthroughs, like robots that do factory work, or run as fast as a cheetah, or leap tall buildings in a single bound. You know, robots are even revolutionizing cat transportation. But perhaps the most important invention is machine learning.
And there are 2 reasons why I believe machine learning is so important. Let's take a couple examples here. So I will show a competitor tool. I hope I don't get fired by this, but let me show you something in Google Docs. I'll just create a new document and write something like, Eekland is an Eekland. So I made the same typo twice, but if we ask for spelling here and change with default settings, you see that it says Iceland is an island. That's correctly not in the grammatical sense, but logically correct, because they have the whole internet of data to discover and try to see how is this phrase most common and what I probably want, and this makes total sense. So the idea here is that you can build systems where you don't have to program explicitly every case, but feed the system with data and let it infer the rules, right? And this can be very, very transformative, right? At Amazon, we are using that since the first launch. This is the first Amazon website, even older than 10 years older than the other one. And it launched with EYES, a personal notification service. That's our recommendation system. Like people that bought this book would probably buy these others, or your friends are also seeing this, so you might want that, and things like this. But we are pretty beyond recommendation systems nowadays, right? They're pretty important. They are the key for this collaboration, because the machines can make the suggestions and the humans can make sense of this and reject or accept the suggestions from the machines. But we've moved it way beyond. For example, in Amazon Go.
What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store, so you never have to wait in line? No lines, no checkouts. no registers. Welcome to Amazon Go.
So Amazon Go is this store in Seattle where you can just pick the things in the shelves and go. You don't have to pay. You don't have to pay in the cashier or be blocked by anything. You just enter the store. Visual recognition will track you through the store. You can pick things, you can put it back, and it will delete the things. I tried. It's really like this. And you can just go with the things you picked on the shelves. And it's pretty much like theft, but it goes in your Amazon account. And this is not available only for us. We are making the components of that available as AWS services. This is Amazon Recognition. You can use it for image recognition, obviously. This case is my bike, and it can clearly detect that it's a bike. It's not a mountain bike, it's a fixed gear, but I won't complain for that. And this can power the same kind of solution. If you see, let's take a look at the recognition service. It's on the console. You can just go to recognition and try it for yourself. And in this case, there's a skateboard, sport, people, human, and all this data is available not only through the UI, but you have to think that all AWS services are HTTP based. So this is just a client. We have the command line client. We have clients for Java, JavaScript, PHP, Node, every major programming language. And you can integrate this with applications very easily. This is feature detection. We also have image moderation to see if there is, for example, suggestive content, nudity, and things like this. Facial analysis. It can see if the person is smiling, even with more than one person in the picture. It will show if it's a male, if it's happy, if it wears glasses, if its mouth open, has a beard, mustache, even the age range. See? Let's see if I can show you something else. So I probably have a picture of me here. This is a good one. So I'm between 35 and 52 years old. So that's pretty correct. And I'm smiling, and you can see the kind of things that you can build. It can also detect celebrities. For example, Bezos is matched here, or Andy. And it's a huge database of celebrities. But perhaps one more useful case for apps is face comparison. It can compare faces against its previous examples, and you can use this for authentication or for recognition or for helping people that are visually impaired and all those sorts of things. And this is a very common trend to help machines have human senses, and it does not stop at faces. You can do this for lots of services. Here, let's show another one. For example, here you can find the AI services, Lex for chatbots, Poly for voice, recognition for vision, and machine learning for recommendation systems. And let's try Amazon Poly for speech. So I will pick Portuguese as a language. We can choose the voice, and the message.
Olá, o meu nome é Inês. Espero que estejam gostando do piso.
E esse tipo de coisa. Então, tem muitas funcionalidades em todos esses serviços, muito mais do que a gente poderia mostrar aqui. For example, SSML is a language that you can use to highlight the text and say how you want things to be spoken. For example, let's pick, there are tags to say things as spell out or cardinals or fractions or even whisper. There is a effect to whisper things. So let's get it to whisper.
Olá, o meu nome é Inês.
So this, of course, is to make machine learning accessible to everyone. This is all based on deep learning technologies, specifically on the Apache MXNet. So if you're using MXNet, you're probably seeing how this kind of stuff works. But one very common issue is that this model is not very flexible. It's trained to do this, and there's not much you can do if you would like, for example, recognize cat faces or aliens or whatever you're trying to recognize. But another aspect of AWS that I find important is that you can work on different layers, on different levels of abstraction. So for example, if you're an expert on Spark and building machine learning with Apache Spark, that's a very popular machine learning solution. You can use Apache Spark on EMR. That's our clustering service, our distributed computing service. And the idea here is that EMR will take care of setting up yarn, resource negotiation, spinning instance types, storage nodes, compute nodes, and build your cluster the way you tell it to build. And you can just submit your Spark job and let the cluster do its thing without having to worry what resource is local, what resource is not, and optimize and config files for Hadoop and things like this. So this makes it pretty interesting. But you can say that, I want to dive deeper. I want to work on the hardware level, on the instance level. And you can. Actually, one very important thing for machine learning is that we now offer FPGA instances. So field programmable gate arrays, or FPGAs, are custom hardware chips that you can deploy your own mapping of ports, and it will configure itself to your code. So there's a common law that 80% of the time, you're running only 20% of your code, and if you compile that to hardware, it can run much faster. Typically more than one order of magnitude, like 10 times faster, because you compile it to hardware. So we have instances with FPGA where you can compile this and build your own custom hardware. And you can publish this to the marketplace or consume from the marketplace. So if you are that guy that I was talking about that really wants to go deep and build machine learning hardware with FPGAs, we do have a couple of customers that this is their specialty, and they are publishing their solutions on the marketplace. If you're on the other side of things, that you don't want to know about it, how an FPGA works, you just want fast machine learning, you can just go to the AWS marketplace, pick the image with the solution you like, and you will have FPGA acceleration. And this is pretty much how it works. So this is another example.
Amazon is developing a service to use drones to safely deliver packages to customers in 30 minutes or less. It's called Prime Air. We've started a new private trial for customers in the Cambridge area of England, and on December 7th, we completed our first delivery. Customers will choose from a selection of thousands of items tucked away in a Prime Air fulfillment center located just over the horizon from their homes. We have been operating fulfillment centers for quite a while now, but this one is unlike all the rest. These modest-looking buildings contain innovative prime air technology. Here's how it works. Moments after receiving the order, an electrically powered Amazon drone makes its way down an automated track and then rises into the sky with the customer's package on board. These drones are autonomous. From takeoff to landing and return, they operate completely on their own. Cruising quietly below 400 feet, carrying packages up to 5 pounds, and guided by GPS.
So this is not a simulation. We have 2 production customers on Amazon Prime Air. It's not a lot now, but it's surely expanding, and we will see this kind of solution grow more and more. And this is for retail, but you can think the same kind of self-driving cars possibilities that arise with this kind of machine learning technology can be used in a huge number of areas, right? And the last thought that I would like to leave as a takeaway is that this can have so profound implications on our lives and societies that we are just starting to understand it. In this case, picture the possibilities with this kind of drones and deliveries. And one case that I find impressive is the usage of drones in war.
So is featuring a new type of warrior. And it's actually redefining the experience of going to war. You can call this a cubicle warrior. This is what one Predator drone pilot described of his experience fighting in the Iraq War while never leaving Nevada. Quote, "You're going to war for 12 hours, shooting weapons at targets, directing kills on enemy combatants. And then you get in the car and you drive home. And within 20 minutes, you're sitting at the dinner table talking to your kids about their homework."
So this is an example from a TED talk about using drones in the military. In this conflict in the Iraq, it was just the first model of this. It was like nothing compared to what's being used in nowadays combats. But even by then, the story that the soldier tells is he can go to war 12 hours a day, kill enemies, destroy installations, and go back into his home in time to have dinner with his kids and ask how was school. It's certainly a very different experience of going to war that we have been in mankind so far. And it is very hard to discuss this kind of questions because we're not nearly ready for this, right? We can't even decide if Uber is legal or not, how we are talking about self-driving combatants at war. So I think that our role as a technology, as our developer, is just as much on engineering as it is on citizenship these days. Because if we can't drive these things to market, if we can't have the proper legals and support and society for what we are building here, then it's useless, right? So this is, to me, the most important thing. Don't just be engineers, but try to be citizens and engage in the discussions that you find important. If you'd like to know more about this and what's going on and keep up to date with the innovations and trends on AWS, we have a What's New page that features new services and new announcements every couple of days. If you're in the hackathon, Randall Hunt from our evangelist team built a very nice talk, How to Win a Hackathon, full of ideas for developing quick projects and hopefully win this hackathon. And to help you guys win this one, I am offering $50 in AWS credits for any amount of EXP or any EXP. Just send me one EXP or how many you would like, and ping me on Twitter, JM Faerman, and I will send you a code worth $50. Okay? Thank you very much. Enjoy Pixels Camp. If you have any questions, I will love to hear them now or anytime at all. Thank you.